Today, we're going to break down some of the most fundamental ideas in artificial intelligence. We'll look at how an AI model actually goes from knowing nothing to making some seriously smart predictions. And look, this stuff matters. These are the invisible gears turning behind your social media feeds and the AI you're probably using for your assignments.
Let's just dive right in. At its heart, AI learns through experience, through a ton of repetition. It doesn't get things right on the first try. It has to practice. So the big question is, what does that practice session actually look like when it's a machine doing the learning? To make all of this super clear, we're going to stick to one simple analogy for this whole explainer. Imagine that the enormous data set an AI trains on is just a textbook, and the whole training process, well, that's just one long, intense study session. So let's get to our first big concept and see how this all builds up. We're going to start with the biggest piece of the puzzle, the act of reading that entire textbook, from cover to cover. In the world of AI, we call this an epoch. The definition of an epoch is actually pretty straightforward. It just means the AI model has seen every single piece of data in its textbook, every last image, every sentence, every data point, at least one time. Think of it as one full review of all the material.
And that's really the key takeaway here. So if one epoch is one read-through, telling the model to train for 50 epochs means it's going to read that same textbook 50 times over, getting just a little bit smarter and refining its understanding with every single pass.
But let's be real for a second. No one, not even the most dedicated student, crams an entire 1,000-page textbook in one go. You break it down, right? You study it chapter by chapter. Well, it turns out AI does the exact same thing.
For practical reasons, like limits on computer memory, we can't just dump the entire dataset into the model all at once. So instead, we feed it these smaller chunks, which we call batches. You can think of these batches as the individual chapters of our textbook. The model studies a chapter, sort of pauses to update what it's learned, and then moves on to the next one.
This slide just shows the simple math behind it. If our textbook has 80 images total, and we decide our chapter size, our batch size, is going to be 16 images, well, it'll take 5 of those batches to get through the whole book. The model chews on 16 images, learns from them, and then grabs the next 16.
So here's the crucial link between these two ideas. An epoch is simply made up of all the batches. As soon as the model gets through that very last batch, it has officially completed one epoch. You finish all the chapters, you finish the book.
Okay, so we figured out what our AI is studying, that's the epoch, and how it's breaking it all down, that's the batch size, but now we have to decide how fast should it learn? What's the right pace for this study session? This is all controlled by something called the learning rate. You can think of the learning rate as the size of the steps the AI takes as it gets closer and closer to the right answer. Is it taking tiny, super careful, meticulous steps forward? Or is it taking these huge, confident leaps? That's what we're controlling with the learning rate.
And as you can see, there's a really critical trade-off here. A small learning rate is the safe, steady route. But wow, training can take forever. A large learning rate is way faster, but it's also a lot riskier. The model might learn so aggressively that it completely jumps over the best possible solution and never even finds it.
And that quote right there really just nails it. There's no magic number, no single best learning rate that works for every situation. Finding the right one takes a bit of intuition, some experience, and honestly, a lot of trial and error. It really is more of an art than a science.
All right, let's bring all three of these ideas, epochs, batch size, and learning rate, together. Because in the real world, they don't operate in a vacuum. They're all part of this interconnected system that a data scientist has to balance really, really carefully.
The best way to think about these three settings, which are technically called hyperparameters, is like the dials on a control panel. By turning these dials, you're deciding on the entire personality of the AI study session, how many times it rereads the material, in what size chunks it studies, and at what speed it learns.
And the whole goal of messing with these dials is to find that perfect sweet spot. If you have too few epochs, the model underfits. That's like a student who just barely skimmed the textbook. But if you have too many epochs, it overfits. It basically memorizes the book, including all the typos, and then can't answer any new questions that aren't quoted directly from the text.